At the end of the topic, you will be able to state Archimedes' principle, explain and verify Archimedes' principle. Now let us discuss a very interesting story about Archimedes and his principle. In 1st century BC, King Hiero II of Syracuse ordered his goldsmith to make him a new gold crown wreath. The gold was weighed and given to the goldsmith. When the king received the finished crown wreath, the crown was weighed. The weight matched the original weight of the gold. The king suspected that the crown was not pure gold. Some amount of gold might have been replaced by silver, so he asked Archimedes to uncover the fraud in the manufacture of golden crown wreath. The story goes that when Archimedes lowered himself into his bathtub full of water, the tub overflowed, which inspired Archimedes to discover the solution to the crown problem. With much excitement, Archimedes jumped from the tub, forgot to dress up in his toga, and rushed down the street to the palace yelling, "Eureka! Eureka!" To test the crown, Archimedes weighed it first in the air and then after immersing it in water. For example, let us consider that the crown weighs 1000 grams in the air and 900 grams when immersed in water, and hence the buoyant force is 100 grams. The density of water is 1 gram per centimeter cube. It can be substituted to get the volume of the crown. Using the formula to calculate the density, that is, mass per volume, the density of the crown would be 1000 grams per 100 centimeter cube or 10 grams per centimeter cube. The value obtained is very different from 19 grams per centimeter cube, the density of gold. This way, Archimedes identified that the goldsmith alloyed the gold with a cheaper metal and kept the extra gold for himself. Archimedes' principle states that an immersed body is buoyed up by a force equal to the weight of the displaced fluid. The weight of the displaced fluid is called the buoyant force.
Archimedes invented the water screw for irrigating the fields of Egypt. He discovered the principle of lever and is reported to have said to the king, "Give me a place where I may stand and I will move the world." He invented many mechanical devices to drop heavy weights on Roman ships which attacked the Greeks.
When you try to push a beach ball into water, the upwards force you feel is called the buoyant force, also called upward thrust. If an object floats on water, then the force F1 is the weight of the object acting downwards. Force F2 is the upward thrust of the fluid pushing the object upwards. The resultant weight, that is F2 minus F1, is less than the original weight F1 of the object. The body loses weight equal to F2, which is the upward thrust acting on it. The difference of F2 and F1 is the apparent weight of the body inside water. The object floats if the upward thrust is enough to support the object's weight. The object displaces just enough water so that the upward thrust is equal to its weight. If the object displaces as much water as possible and the displaced water does not match its weight, the object sinks. Objects with lesser density than water always float. Now let us verify Archimedes' principle. Consider an object that is fully or partially immersed in a fluid. It experiences an upward thrust equal to the weight of the fluid displaced. If W1 is the weight of the stone and W2 is the weight of the stone in water, then the loss of weight of stone in water would be W1 minus W2. Similarly, if the weight of the empty beaker is W3 and the weight of the beaker with displaced water is W4, then the weight of the water displaced by the stone is W4 minus W3. The apparent loss of weight of body in water W1 minus W2 is equal to the weight of the displaced water W4 minus W3. Therefore, when a body is wholly or partially immersed in a fluid, it experiences an upward thrust equal to the weight of the fluid displaced. Click the animation to understand more. In this topic, you have learnt Archimedes' principle states that an immersed body is buoyed up by a force equal to the weight of the displaced fluid. The weight of the displaced fluid is equal to the buoyant force. Buoyant force is also called as upward thrust. If the object displaces as much water as possible and the displaced water does not match its weight, the object sinks. Objects with lesser density than water always float. At the end of the topic, you will be able to define relative density, determine relative density of a solid, calculate relative density of liquids using Archimedes' principle. Objects can float on the surface of liquid if they have less density than the density of liquid. From Archimedes' principle, we understood that the weight of the floating object is equal to the liquid displaced by it. Objects which have greater density than water immerses in water. When we weigh the object immersed in liquid, there is apparent loss of weight. This loss of weight due to the upward thrust of the liquid is equal to the weight of the displaced liquid. Also, the volume of the object immersed in the liquid is equal to the volume of the liquid displaced. Based on this, liquid relative density of any object can be calculated. In the following slide, we will discuss the method to determine the relative density of solids and liquids. Relative density is the comparison of density of any substance with the density of water. By the application of Archimedes' principle, we can determine the relative density of a solid if we know the mass of the solid object and the mass of equal volume of water. That is, the relative density of solid substance is equal to mass of any volume of substance in air divided by mass of water of an equal volume. We know that weight of the object is proportional to mass. Hence, the relative density of substance is equal to the weight of any volume of substance in air divided by the weight of equal volume of water. But the weight of equal volume of water is equal to the apparent loss of weight of substance in water. Therefore, the relative density of a solid substance is equal to the weight of any volume of substance in air divided by the apparent loss of weight of a body in water. If the weight of an object is W1 in air and W2 in water, then the relative density of that object is equal to W1 divided by W1 minus W2. Here, W1 minus W2 is the apparent loss of weight of that object. Relative density has no unit. Consider a stone, 45 gram weight in air and 36 gram weight in water. Then the apparent loss of weight is weight of stone in air minus weight of stone in water, that is 45 minus 36 is equal to 9 gram weight. The relative density of stone is equal to its weight in air divided by apparent loss of weight of it. Thus, relative density is equal to 45 by 9, which is equal to 5.
A brass bob can be used as a sinker in order to keep the cork in water. Suspend the brass bob from the left scale pan. Immerse it in a beaker of water placed on a hydrostatic bench. Find the mass m1. Tie the cork to the same string in such a way that it is in air and the brass bob is in water. Find the mass m2. Tie the cork together with a bob. Immerse both of them in water. Find the mass m3. Mass of the cork in air is equal to m2 minus m1 grams. Mass of the cork in water is equal to m3 minus m1 grams. Loss of mass of cork in water is equal to m2 minus m1 minus m3 minus m1 grams is equal to m2 minus m3 grams. Relative density of cork is equal to mass in air divided by loss of mass in water, which is equal to m2 minus m1 divided by m2 minus m3. It has no units.
Next, we will learn to determine the relative density of liquids. When we immerse an object in liquid, there is apparent loss of weight of the object. The apparent loss of weight depends on the density of liquid in which the object is immersed. If the density of liquid is greater, then the apparent loss of weight of the object in that liquid is greater. The relative density of liquid is equal to the weight of the liquid displaced by an object divided by weight of the water displaced by the object. We can also define the relative density as ratio of apparent loss of weight of solid object in liquid divided by the apparent loss of weight in water. Take a solid object, weigh it with spring balance in air. The weight of the solid object is W1 grams in air. Take two cylindrical vessels. Fill one vessel with water and the other with liquid whose relative density is to be calculated. Now immerse the object in water and weigh it. The weight of the object in water is W2. Take the solid out of the water, clean and dry it. Then immerse the object in liquid. Now measure the weight of the object in liquid, which is W3. Therefore, the relative density of the liquid is equal to W1 minus W3 divided by W1 minus W2. Here, W1 minus W3 is the apparent loss of weight of the object in liquid, and W1 minus W2 is the apparent loss of weight of object in water. In this topic you have learnt comparison of density of any substance with density of water is known as relative density of that substance. The relative density of solid is equal to the ratio of weight of the solid in air to the apparent loss of weight in water. The relative density of liquid is the ratio of weight of the liquid displaced by an object to the weight of the water displaced by the same object.
At the end of this topic, you will be able to define center of gravity and center of buoyancy, describe the laws of flotation.
Every object is made of tiny particles. Each particle present in objects possesses weight. Weight of the object is equal to the sum of weights of all particles present in the object. The entire weight of the object appears to act at one particular point in the object, which is known as center of gravity. When an object floats on water, it displaces some volume of water. The center of volume of displaced water is known as the center of buoyancy. With this idea, we will now learn about the floating objects. Consider a body floating freely in a liquid. The weight W of the body acts vertically downwards through the center of gravity G of the body. The total upward balancing force T acts vertically upwards at the center of buoyancy H. This total upward force is called thrust. This thrust is equal to the weight of the liquid displaced. The floating object will be in a well-balanced state when its weight is equal to the thrust and the points G and H lie in the same line. This state of the body is called equilibrium. When this is attained, the body floats freely in the liquid. According to the laws of flotation, the weight of the floating body is equal to the weight of the liquid displaced by it. The center of gravity of a floating body and the center of buoyancy are in the same vertical line. Hydrometers are used in many ways. They are used in pathological labs, factories, breweries, and research centers. They are also used to find the strength of brine solution and the specific gravity of seawater in the different seas and oceans. These kinds of hydrometers are called salinometers. They are used in dairy farms to test the specific gravity of milk. These kinds of hydrometers are known as lactometers. In a lactometer, the topmost reading gives the density of water and the bottommost reading gives the density of pure milk. They are used as a refractometer to measure the density of acids in batteries. They are used to test the specific gravity of urine. This type of hydrometer is called uranometer. They are also used to test the specific gravity of alcohol. These types of hydrometers are called alcoholometers. In this topic you have learnt, the weight of the floating object is equal to the weight of the liquid displaced. The center of gravity of the floating body and the center of buoyancy are in the same vertical line. The upward thrust exerted by a liquid is equal to the weight of the liquid displaced. Constant immersion hydrometer is also called Nicholson's hydrometer. Hydrometer is used to measure the relative density of a liquid.
At the end of the topic, you will be able to state Boyle's law, verify Boyle's law with an experiment, state Charles' law, express the gas equation, explain Kelvin scale of temperature.
Hydrometer works on the basis of the law of flotation and Archimedes principle. It is used to determine the specific gravity of liquids. There are two types of hydrometers: variable immersion hydrometer or common hydrometer, constant immersion hydrometer or Nicholson's hydrometer. Click each type of hydrometer to learn more. In this type of hydrometer, the weight of the hydrometer is kept constant, but the depth of immersion varies depending on the density of the liquid in which it is floated. It immerses to varying depths in different liquids. In this hydrometer, the depth of immersion is kept constant, whereas the weight of the hydrometer is changed to make it float to the same depth. So it is immersed to the same extent whatever the liquid may be. A common hydrometer immerses to different depths in different liquids based on its working principle. That is, if a common hydrometer immerses to a certain extent in water, then it immerses to a greater depth in kerosene, as the density of kerosene is less than the density of water. Similarly, it immerses to a lesser extent in castor oil, as the density of castor oil is more than the density of water. This animation will help you to know more about hydrometers. Now, we will see the construction of a common hydrometer. A common hydrometer consists of a hollow cylindrical bulb B with a long, narrow stem AM on which graduations are marked. The bottom end of the cylindrical bulb is joined to a comparatively small bulb L. This bulb is loaded with mercury or lead shots so that the instrument floats vertically in all liquids. For calibrating the hydrometer, you may follow these steps. Float the hydrometer freely in water contained in a jar. Mark the point M on the stem up to which the instrument sinks in water. Let V be the volume of the hydrometer up to the mark M. Now float the hydrometer in a liquid of density ρ. Mark the point A on the stem up to which the instrument sinks in the liquid. Let the distance AM be L and let S be the area of the cross-section of the stem. After calibration, we can say that the weight of the water displaced is equal to V into density of water. That is, V into 1 is equal to V, density of water is 1 gram per cc. The weight of the liquid displaced is equal to rho into V plus L into S, where L is the distance AM and S is the area of cross-section of the stem. And according to the law of flotation, the weight of the floating body is equal to the weight of the liquid displaced. The distance L is equal to V into 1 minus rho divided by S rho. The distance L for various values of rho is calculated and the corresponding points are marked on the stem. To determine the specific gravity of the liquid, the hydrometer is floated in the liquid and the reading on the stem corresponding to the liquid surface is noted. The reading gives directly the specific gravity of the liquid. Hydrometers are used in many ways. They are used in pathological labs, factories, breweries, and research centers. They are also used to find the strength of brine solution and the specific gravity of seawater in the different seas and oceans. These kinds of hydrometers are called salinometers. They are used in dairy farms to test the specific gravity of milk. These kinds of hydrometers are known as lactometers. In a lactometer, the topmost reading gives the density of water and the bottommost reading gives the density of pure milk. They are used as a refractometer to measure the density of acids in batteries. They are used to test the specific gravity of urine. This type of hydrometer is called uranometer. They are also used to test the specific gravity of alcohol. These types of hydrometers are called alcoholometers.
Take 2 tall jars of the same capacity, fill one of them with water and the other with a given liquid whose specific gravity is to be found. Take a graduated test tube and add lead shots or sand to make it heavy so that it floats vertically. Tie a long thread near the mouth of the test tube to enable us to lower the float in the jar. Immerse the loaded float first in the jar of water. Take care that the float does not touch the sides or bottom of the jar and there should be no air bubbles sticking to the sides of the float. Note the depth of immersion in water, H1, without parallax error. Gently take the float out from the water. Wipe the water droplets on the sides with a clean cloth. Now gently lower the float into the jar containing the liquid. Do not add or remove any lead shots. Note the depth of immersion of the float in the liquid, H2. Specific gravity of the liquid is equal to depth of immersion of the float in water divided by depth of immersion of the float in liquid, which is equal to H1 by H2. Now add or remove a few lead shots and repeat the experiment. Note down H1 and H2 in each case. Repeat the experiment and tabulate the readings. Take the average value of H1 by H2, which gives the specific gravity of the liquid. Weight of water displaced is equal to AH1D1G. Weight of the liquid displaced is equal to AH2D2G, where A, area of cross-section of the float, D1, density of water, D2, density of liquid, G, acceleration due to gravity. Since the weight of the test tube float is the same in both the cases, weight of liquid displaced is equal to weight of water displaced. AH2D2G is equal to AH1D1G. D2 by D1 is equal to H1 by H2. Specific gravity of the liquid is equal to H1 by H2. Make the test tube float in water vertically to a certain height h. Take care that the test tube float does not touch the sides or bottom of the jar. Take the float out and wipe the outside dry. Find the weight of the float in water, say W1. Now make the test tube float in the given liquid. Add or remove lead shots so that it floats to the same depth h. Take the test tube float out and wipe the outside dry. Find the weight of the float in liquid, say W2. Repeat the experiment for different depths and tabulate the readings. As the depth of immersion of the float is the same in both cases, the volume of water and the liquid displaced are same. According to the law of flotation, the weight of the floating body is equal to the weight of the liquid displaced. Weight of the water displaced W1 is equal to AH D1G. Let it be equation 1. Weight of liquid displaced W2 is equal to AH D2. In this topic, you have learnt variable immersion hydrometer and constant immersion hydrometer are the two types of hydrometers. Hydrometers are used to determine the specific gravity of liquids. It is constructed on the basis of laws of flotation.